Tonight we're trying to find a real valued solution to this logarithm exponential equation. Now we better go ahead and specify that the base is strictly greater than 0, and that's simply because the logarithm function, b's all over the place, but b is also the base of the logarithm, so b has to be positive for real valued logarithms, okay? Now let's get moving. Now this very first line just follows from the fact that if you have b, we'll just use something like this, b raised to, let's say, the u equals to b raised to the, say, v power. The exponential function is 1 to 1. So this implies something that looks fairly obvious, but we do need the function to be 1 to 1. Any function that would have this property would have to be a 1 to 1 function. You could think about the squaring function, you know, and this wouldn't happen for the squaring function since it's not 1 to 1, but u has to equal to, or v has to equal to u. We write it either way, right? And that's exactly what I did right here, folks, because notice we have b raised to the b over this log equals to 1 over b raised to the b. Now notice that, where does this come from? 1 over b raised to the b. And this is just properties of exponents, is the very same thing as b raised to the minus b. Okay. So this property of the exponential function, combined with the fact that 1 over b raised to the b is just b to the minus b, is where this minus b actually came from, because we just remove the base and equate the two exponents. Well, the exponent would be minus b, and then this object right here, which is exactly where this statement comes from. And this is easy as it looks. I overlooked it for a little while. But anyway, this property implies this. Now, if you multiply through by log base b of x and divide by minus b, you get this statement right here. You get log base b of x equals to minus b over b. Now we know that b is strictly greater than 0, and so this is just minus 1. And of course that's equivalent to x being equal to b to the minus 1, which would be the solution. And y'all, that all we're doing on that is just log base b, log base b of b raised to any power of b raised to any power, we'll call it n, I guess, if you want. Since these are inverse functions, the answer to this is just n, okay? And so you can see your n is just -1 in this particular case, because we have log base b of x equals -1. So x does have to equal to b to the minus 1 for that to happen, okay? So x is just b to the minus 1. That's equal to 1 over b. Let's work a concrete example. We'll choose the base to be 7, and we see very quickly that x is just equal to 1/7. So I wouldn't say it's a lot of symbol mashing. It's really not particularly difficult. It's just a lot of symbol manipulations and properties of exponents that led to the solution of this problem. So that's it, folks. Thank you for viewing.